Welcome to H Classroom series. I am Daniel Qureshi, and in this third lecture, we are going to see these two very rare topics. Okay, first one is the concept of circuit ground. Okay, and second one is the negative voltage and dual power supply. So make sure that you watch till the end. So now we'll see the concept of ground. Concept of ground, is one of the most misunderstood concepts. Okay, this word ground is actually very much misunderstood by majority. Okay, this symbol you may have seen. Okay, this is the symbol of ground and many people, okay, majority of them, okay, maximum of them, whenever they see this symbol in any circuit, they actually think that it is nothing but just the negative terminal of the battery or the negative terminal of the power supply. Okay, so they just think directly that this ground actually is basically the negative terminal of the battery. Okay, so they actually connect that particular terminal to the negative terminal of the battery. Now this is not exactly true. This is partially true but not exactly true. Ground can be anything, because by definition and in very simple terms, ground is nothing but a reference point. Okay, a reference point, it is something from which we take reference. Okay, from which we measure voltage. Okay, that is the reference point, and it can be anything. Okay, so let us understand. See the first circuit, you can see that the ground terminal is actually connected to this negative terminal of the battery. Okay, so the symbol is connected with the negative terminal. Now here, ground is basically a reference point, so its voltage is considered to be zero. Okay, its voltage is actually considered to be zero. Its absolute voltage is considered to be zero. Okay, absolute potential of ground can be determined because it is voltage difference between that same terminal. Okay, with respect to the same terminal, so it will be zero. Okay, it is exactly the same as voltage difference between 2 points on a wire or on a conductor is basically zero, because that is with reference to the same conductor, so that will be zero. But here the other terminal of the battery, let us denote it with S. Okay, so it denotes the supply side of the battery. Okay, so here you can see that if you want to find the supply voltage that is coming here. Okay, now 5 volts is the voltage rating of the battery that is given. Okay, so VSG. Okay, now VSG is nothing but potential difference between these 2 points S and G. Okay, with respect to G. And how with respect to G? Because we have given this symbol. Okay, this ground symbol actually tells us that this reading or this voltage that we are measuring should be with respect to this ground terminal, and now this ground terminal is nothing but this negative. Okay, it is connected to the negative terminal. Okay, so according to the battery manufacturer, 5 volts is basically the voltage of this positive side with respect to this negative. Okay, according to the battery conventions. So definitely you can see VSG equal to VS minus VG. Okay, VS minus VG, definitely voltage of this potential of this, okay, of this terminal minus potential of this ground. Okay, so ground potential is definitely zero. And how VS is 5? How VS is 5? Because battery manufacturer itself has specified this. Okay, with respect to that negative terminal, it is actually 5 volts. So definitely we write here 5, and 5 minus 0 equal to plus 5 volts. And definitely you can directly see from here VSG is nothing but 5 volts. Okay, so it is only possible when you know, okay, where your ground terminal is. Now let's see, here is the diode. Okay, so definitely a current will flow. Okay, and this is a light emitting diode. Okay, and it will glow. Okay, after the current will flow, and here we saw that current was flowing in this direction. Okay, but what will happen if instead of putting that ground terminal at the negative terminal of the battery, we put it on the positive terminal of the battery? Whether the circuit will be affected? Okay, will the circuit work the same way as it did before? Yes or no? The answer is, the placement of this ground doesn't affect the working of any circuit. Okay, it doesn't affect, because this is current electricity, direct, it will find the path, and there is no relation with it with this ground. So what this ground actually tells us, okay, the current will still flow. Okay, the current will still flow. The polarity of the battery is the same, you can see at the both side. Okay, and even the light emitting diode LED is also in the same polarity, so it will definitely light up. So why don't we connect usually our ground to the positive supply? And is it ethically correct? Ethically it is actually correct, okay, because you can connect ground anywhere, okay, anywhere, even at the positive terminal, negative terminal, or any other point in the circuit, okay. Now let's see the difference between the interpretation of voltage, okay. So as you can see that the ground terminal is connected to the positive side of the supply, okay, positive terminal of the battery, and other terminal will definitely be S, okay, because opposite terminal of the ground is definitely the supply side that we consider, okay, generally. So VSG, okay, voltage difference between S and G, what it is with respect to this ground, okay, with respect to this ground, and now the ground is actually connected to the positive terminal, okay. So all the voltages in the circuit, not just this, all the voltages in the circuit, even the voltage across this LED, okay, even the voltage across this resistor, okay. So all the voltages throughout the circuit will be measured with respect to this terminal, okay. And same was the case with this, but instead of that, the ground was connected at the negative terminal, okay. So let's see what happens, okay. VSG is equal to VS minus VG, okay. So VG definitely 0. Why? Because a voltage of this point with respect to this point will definitely be 0, okay. And VS, now VS, how to find out VS, okay. Now according to the battery manufacturer, voltage difference between these, okay, is 5 volts with respect to this terminal, negative terminal. But what we want, we want VS, and VS, what we want is VS, VS is the voltage of the voltage difference between these with respect to these, okay. So we know voltage difference between these two terminals with respect to this, and that is 5 volts. So it will be opposite of that, and that will be minus 5 volts, okay, minus 5 volts, because we have to consider voltage with respect to this new ground, and that ground is connected to the positive terminal, okay. So that's why it will be minus 5 and minus 0, and this actually means that your supply voltage is minus 5 volts, okay. This is the interpretation. So what is the reason we prefer adding the ground terminal to the negative terminal, okay, or considering our ground terminal to be the negative terminal of the battery and not at the positive terminal? The reason is very simple. Just look at these calculations. You will see that the voltages which we are calculating using this method, okay, when the ground is considered to be the negative terminal, the voltages are actually positive quantities or actually positive voltages, okay. And that's why it is very much easier, okay. Even the voltages, voltage drop across this resistor, voltage drop across this LED will be positive. But in this case, where the ground is considered to be the positive terminal of the battery, here look at the calculation, okay, you can see definitely that the voltages are negative, okay. And same will be the case with the voltage drop here, voltage drop across any other elements throughout the circuit, okay. So working with negative voltages, you have to add negative voltages, and then they'll add up, and then you again have a negative sign. So it is actually not so much beneficial as compared to this, okay. So that's why we actually use this ground more with the negative terminal as compared to that with the positive terminal, okay. And another thing is, battery manufacturers actually specify their polarity, okay, actually specify their reference, and their reference is definitely with respect to the negative, okay. So for example, this battery is 5 volts with respect to this negative, so why not use that same negative terminal as our own reference, okay. So that is how we can simplify our further calculations. And what we can conclude from this is, wherever you see this symbol, this ground symbol, don't just simply confuse it with directly the negative terminal of the battery, or don't just think that it can be directly connected to the negative terminal, okay. First see and look out throughout the circuit, and then you'll understand. Now let's see what exactly negative voltage is. Can it really exist, or is it something magical? Like how voltage can be negative, as it is just merely a potential difference, okay, difference in potential. So how can it be negative? Let's see how. Let's have a look on an example. We have 1.5 volt zinc carbon cell, and we also have a multimeter in order to check the voltages, okay. Here we are going to use the same concept of ground that we have studied earlier. Now we can measure the voltage of the battery in two ways, as we have two probes here to measure the voltage at the multimeter side, and we also have two terminals in this battery. So there are two possible ways in which we can measure this voltage of battery. And the first way to measure the voltage would be to connect this ground terminal, or this is actually called as the common terminal. Okay, this ground terminal to this negative terminal of this cell, and this V terminal to this positive terminal. Okay, and if we connect like this, we'll actually get positive 1.5 volts, obviously. And this positive reading goes hand in hand with the supplied information by the battery manufacturer itself. That is, the voltage of this battery is 1.5 volts with respect to this negative terminal, and this actually tells that the negative terminal is actually the reference terminal itself from where the voltages are to be measured. And in the second way, we actually reverse those connections and connect the ground terminal of our multimeter to the positive terminal of the battery, whereas we connect this voltage probe to the negative terminal. And now, as our ground is connected to the positive terminal, now this positive terminal will be treated as a reference for measuring voltage. So according to the manufacturer, if the voltage of this terminal is 1.5 volts more than this reference terminal, that is negative, then if you are measuring it in the reverse direction, okay, so definitely you will get a negative sign. And this is exactly where negative voltage is generated. So well, if one time the voltage is positive and other time it is negative, so which voltage is actually correct? What should we consider? And the answer to this question is very simple. You have to consider the same reference which the battery manufacturer suggests, and that reference is nothing but this negative terminal. And only then you will be able to find out that exact voltage. So it all boils down to a very simple concept of ground, okay, from where you are taking your reference, okay, and from that reference you are measuring, okay, and that exactly is why the concept of ground is very much important. So negative voltage is just a perception, okay, what exactly you perceive with regards to your reference. So it's the same thing as we have negative velocity, negative acceleration, negative mass. So if you think logically, velocity can be positive or zero, but how can it be negative? It's just a mathematical tool, okay, to represent that reference, okay, or that direction. So we can think that same way in for this voltage as well. So let's clear things more in our next example. Okay, so here is a series arrangement of these two cells. As you can see, mostly you may have seen this connection in consumer electronics like remote and other controls, okay, where it is used to build up the voltage from 1.5 volts to 3 volts. Okay, if you connect two voltages in series, it actually adds up to get a higher voltage. But here, what if we connect this in a fashion where we also take a ground terminal from this common terminal, okay? So here we get an equal and opposite voltage separation as we have a common ground terminal between these two terminals. As you can see, we have positive 1.5 volts and a negative 1.5 volt. We can also see how exactly we are getting positive and negative voltage at the same time by recalling the concept of ground. Here you can see, as provided by the battery manufacturer, the voltage of this terminal is actually higher than this terminal. So with respect to this terminal should actually be at a lower potential, and that's why here negative polarity is given, and same is the case with the above cell, and that's why we are also getting a positive as well as a negative voltage. Such an arrangement which gives us positive as well as negative voltages with respect to ground is referred to as a dual power supply. This is the most simplistic form of a dual power supply. So unlike any single power supplies which have two terminals, dual power supplies actually have three terminals. Okay, so the earlier mentioned example of dual power supply using the two cells is not very much practical, okay. It is actually okay for low power applications, but for high power applications, it is not so much practical, and that's why there is a need to convert the conventional single power supply to a dual power supply. So let's see how it is done. Before proceeding further, I would like to share one of my experiences. At that time, I think in my 5th semester, and I was giving my practical viva. And during that external practical viva, the external asked us about the dual power supply, and we all were very surprised, as we were not expecting such kind of questions to be asked. Although it was related to the subject, but not directly, because there were no signs of dual power supply in our entire syllabus. Nobody knew the answer. But fortunately for me, I was already familiar with the dual power supplies, and hence I responded. While I explained the answer to him, he seemed very surprised. I think he was also not expecting answers from us, and especially on this particular topic. So I hope that you'll understand the rarity of this topic. Okay, so here is a practical way of getting a dual power supply from a single power supply. Like it can be anything. Here it is 12 volts. Okay, and if this is a single power supply, then remember that it will just have two terminals. Okay, normally, and one of which is the reference or the ground terminal, and other one is the power terminal, that is plus 12 volts. And here you can see these two resistors are essentially forming a resistive voltage divider network. And these two resistors have actually the same value. And that's why they are dividing this entire complete input supply voltage into two halves. It means that we'll get 6 volts potential difference across this upper resistor as well as across this lower resistor. But as we are considering this middle tap to be the ground or reference of this circuit, we actually get two opposite polarities. Okay, this plus 6 volts and minus 6 volts. But actually in reality, the voltage of this center tap point is half of the original voltage of the input power supply, okay, with respect to the ground. Okay, and half of that is basically 6 volts. So here should be 6 volts, but actually we are considering that 6 volts to be our new reference, okay, of our new dual power supply. And if you are considering the center tap to be our new ground, so definitely the lower terminal will have a negative polarity. And why do we have these two capacitors in parallel to these two resistors? Well, these are filtering or stabilizing capacitors which act as a buffer, removing all the ripples from the input power supply. Ripples are nothing but the AC components of the DC power supply. Or you can think of it as small voltage variation in the DC level or the DC voltage. These capacitors actually smoothens out those small voltage fluctuations and provides a stable voltage at the output. And one thing to remember is that this circuit is not regulated, as it is entirely passive. You can see these passive elements, not a single active element. This is a major drawback, because whenever you try to place any load between any of the lines, okay, it can be like from positive 6 volts to the ground, or it may be from ground to minus 6 volts, or it can also be from plus 6 volts to minus 6 volts, okay, be it any. Normally what happens is this center point actually remains at a stable voltage equilibrium. And exactly how? Because the current which flows from this particular branch has to go from here, okay, and hence they are connected in series. The same current will flow through both of them, and hence that equilibrium position is maintained. But when you connect any load, okay, you are actually creating an imbalance, and that actually shifts the equilibrium to either side. So for example, if we connect the load between the positive 6 volts and ground, so the current required by that load has to come from the source itself, and that current which comes now splits up into two parts, because now there is another parallel load which is connected, and hence the current which would normally flow through this resistor is actually reduced, because then it has an alternate path to flow. It has an alternate path to flow through that particular load, but ultimately those two currents will meet up at this point and has to flow from this resistor, lower resistor R. So this upper resistor is carrying lower current while the lower resistor is carrying higher current. And definitely when the current change, then the voltage across the resistors also change, because V equal to IR. Okay, so here you can see if the amount of current is reducing, okay, then the voltage drop across it will reduce, okay, and if the voltage drop across it will reduce, then this equilibrium, okay, this equilibrium point, this center point, which is also considered to be our ground or reference, its voltage will actually shift towards the positive side, or the positive rail side, or the positive supply side, okay, and it will change the voltage at this common point, which was earlier expected to be somewhere in the middle of the input supplied voltage. Like in this example, it will definitely be greater than 6 volts, okay, like 6.5 volts, 6.8 volts, or 7 volt. It actually depends upon the load which we are connecting. So ideally ground should be constant, which is referred to as 0 volts. But here, as you know, the load is changing, or you know, you are connecting loads unevenly, then definitely your ground is also going to be affected, and hence this is not a well regulated dual power supply. So in commercially regulated dual power supplies, what they actually do is that these resistances are not fixed. They actually use active elements like operational amplifiers or even transistors and things like that. They actually, you know, increase or decrease this resistance and automatically set this resistance according to our load. Okay, so it takes care of all these variations, and hence it provides us with a very stable and regulated dual power supply. See, mostly electronics work well with single power supplies, but there are many cases where we require special negative voltages. And the best example of this is none other than the operational amplifiers. Okay, operational amplifiers, you can search for them, are basic. They are said to be the basic computational elements. Okay, basic computational elements. For example, even before we had logic gates in the era of analog electronics. Okay, in the era of analog computing, so they actually were used as integrators, differentiators, adders and subtractors and things like these. So they actually require dual power supply, positive as well as negative voltage with respect to some certain ground, okay, or some certain reference. And that's it for today, guys. Hope you enjoyed the lecture. In the upcoming session, we are going to see electrical energy sources, not like the wind or solar, but like voltage source or current source and things like that, which in itself is a very huge topic. So make sure that you attend the next lecture. Don't forget to like this video if you enjoyed, and you can comment down below your queries or any suggestions. See you there, and thanks for watching.